This is AS2 June 2013 and we're going to be looking at question 9. So this question is just a standard Hess cycle question. And remember that the equation at the top of your Hess cycle needs to be the equation of the enthalpy change that you're trying to find out. So you're trying to find out the enthalpy change of the formation of propane. Think about what your definition of the standard enthalpy of formation is. It's the enthalpy change when 1 mole of a substance is formed from its elements. So propane is C3H8 and I've got 1 mole of it. What do I need to make propane? Well, I need carbon, and I need 3 carbons, and I need hydrogen, which is H2, and so I'm going to need 4 H2s. Simple as that. The data that I'm given is combustion data. And so when I'm given combustion data, what I write at the bottom of my Hess cycle are my combustion products. So what do I get when I combust carbon? Well, I get carbon dioxide. What do I get when I combust hydrogen? Well, I get water. What do I get when I combust propane? Well, I'm going to get carbon dioxide and water. To balance that, you would get 3 carbon dioxides because you've got 3 carbons, and you would get 4 waters because you've got 4 H2s, or 8 hydrogens on the right hand side as well. With combustion data, your arrows go down. And that's because if you think about it, the enthalpy changes that we're using, the data that we're using is, for example, the combustion enthalpy when we combust carbon dioxide. So that would be your equation for the combustion of carbon dioxide if you imagined that going from left to right. So now it's a case of working out what my values are. So let's first of all write our delta H1, delta H2 and delta H3. So remember, Hess's law states that the enthalpy change for a reaction is independent of the route taken. So it doesn't matter which way you go, provided your initial and final conditions are the same. So we want to know this way, but we don't have that information, but we will have the information for this way and for this way. Okay, so let's think first of all what our delta H2 is equal to. Well, there we have the enthalpy of combustion of carbon, but we've got 3 moles of carbon, so we need to do 3 times our enthalpy of combustion of carbon. Remembering that your definition of the enthalpy of combustion is the enthalpy change when 1 mole of a substance is completely combusted. Okay, we also have hydrogen, but we have 4 moles of hydrogen. So it's 4 times the enthalpy of combustion of H2. Plug in your values. You've got 3 times your minus 394 plus 4 times your minus 286 of hydrogen. And that works out as minus 2326. Then I can work out what delta H3 is. And if I follow that arrow, it's simply the enthalpy of combustion of propane, which I'm given in the question as minus 2219. Now I can work out delta H1 because I know what delta H2 and delta H3 is. Delta H1 is going to be, well, I'm going in the direction of the arrow of delta H2, so it's going to be positive delta H2, but I'm going against the arrow for delta H3, so it's going to be minus delta H3. So delta H2 is minus 2326, and then I'm going to minus my value of delta H3, which is minus 2219. That works out as minus 107 kilojoules per mole, which is answer B. The important thing that you remember with Hess cycles is the equation that goes at the top of your Hess cycle is the enthalpy change that you're trying to find out. So in this case, it was the standard enthalpy of formation of propane. So I form an equation that represents that enthalpy change. Then the direction that your arrows go and what is written at the bottom of your Hess cycle depends on the data that you're given. So you might be tempted to think, because you're asked for the standard enthalpy of formation of propane, that it's your arrows would go up, but it's based on the data that you're given. So the data that I'm given is combustion, so my arrows go down, and what goes at the bottom are my combustion products.